The great thing about trig is that there's more than one way to get your answer, and it will still be correct. So let's say right here that I have this triangle here, and they give me 20 degrees for this angle and 10 for this length of the leg. How would I go about solving for x? Well, I have an angle here, and if I want to incorporate x with this 10, I can say that this angle is opposite to this side and adjacent to this 10. Well, you have to ask yourself, what angle or what trig identity is opposite over adjacent? It sounds a lot like tangent. So, tangent of that angle, 20 degrees, is equal to my opposite over my adjacent. If I rearrange algebraically, I should get x is equal to 10 tangent of 20 degrees. You put this in your calculator, and you should get something about 3.64. Now that's for one side. And of course, as you all are familiar, I can use Pythagorean's theorem, a squared plus b squared is equal to c squared, to get my y value. But again, trig, there's more than one way to get the answer. If I was solving for y, and I want to incorporate my givens, I know that some angle that is adjacent over the hypotenuse. Well, ask yourself, what's adjacent over hypotenuse? That sounds like a lot like cosine. So I can also solve for y as cosine of 20 degrees is my adjacent over the hypotenuse. Rearrange algebraically like I did above, y is equal to 10 over cosine 20, and I should get about 10.64. But let's pretend I didn't know that, right? And I just used Pythagorean's theorem. Well, I should still get the same answer. If I apply here, a squared plus b squared is c squared. Put in my givens. I solved for x already, 3.64, and they gave me 10, and now I just isolate and solve for c. C squared is equal to 113.25, take the square root with both sides, and I should get c is equal to 10.64. Sure enough, these two answers are the same, and I used two different methods to get that same answer. That's what trig is all about. Let's do one more example. This time, they only give me two sides but no angle measurements. How do I go about solving that? Well, let's just start with angle 1. Angle 1 is opposite hypotenuse. Opposite hypotenuse, that sounds like sine. So I'm just going to put sine of theta, I don't know what theta is some ratio that's 16 over 54. Now I'm going to show you some magic. Are you ready? Inverse sine of 16 over 54 is equal to that theta. All I did was just swap these two measurements here. And I can put this in my calculator, and if you're in degree mode, you should get theta is equal to 17.92. And to get my second angle, all I do is subtract from 90, because 90 both here, 90 over here, that's going to be 180. A triangle is 180 degrees in total. You know that. Theta 2 is therefore 72 degrees, about 72.08. Now to solve my other sides, or just my x, again, I could use Pythagorean's theorem, or I can use the very equivalent to solve for x. All you have to do is just know where to look at and what angle to reference.